Now, let's say I want to measure this object with different scales. So here I have the centimeter scale and here I have the millimeter scale. So what is the measurement I can do with this centimeter scale? How can I report the reading? That surely it is between 1 to 2 centimeter. For this, if you observe correctly, I can say it is between 1.4 to 1.5 centimeter. But still I am not sure. What if I need 1.4 and here I need one more digit? I cannot get this much accuracy with either of the scales, right? So in order to report more accurate results, I need something else. So what is that instrument? What can I use for this? This is vernier. So over here we have the vernier scale. It looks pretty much weird, right? So what all are the components of this? So these are known as cross tips. These are known as cross tips. And these are usually used to measure inner dimensions. This is the main scale. This is the vernier scale. We have two scales in vernier caliper, the main scale and the vernier scale. And these are known as jaws. These two are known as jaws. So we use these jaws to place an object in between them. Okay. Usually used to measure the outer dimensions. Next, how can we find the least count? What is the smallest measurement which we can make? So as we discussed, we have two scales, the main scale and the vernier scale. So each division on main scale is known as main scale division, MSD, and each division on vernier scale is known as VSD. Okay, so I hope this difference is very much clear. Then now let's try to answer this question. What is the smallest measurement that we can make with along with this vernier alongside? So now I want you to pause and think about it. I'm going to tell the answer. So is it MSD or is it VSD? Of course VSD looks lesser, but it is it the smallest measurement which you can make on this vernier? No. The smallest measurement is not MSD, not VSD, but this distance. And what is this distance? 1 MSD minus 1 VSD, isn't it? So this is how I tell the least count for vernier. And these two are the coinciding divisions and the length they represent is the same. So can I write 1, 2, 3, 4, 5, 6, 7, 8, 9? 9 MSD is equal to same as this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 VSD, isn't it? This thing is very much given. It can be 8 MSD is equal to 10 VSD or 8 MSD is equal to 11 VSD. It depends on the vernier. Based on this, we need to find the least count. Either the least count will be given directly as a value or this relation will be given in order to find the least count. So how can we find now? 1 MSD minus 1. What is VSD? 9 by 10 MSD. Okay. So if we find this comes out to be 10 minus 9 upon 10 MSD 1 by 10. So this is 0.1 into MSD. And usually it is given that what 1 MSD represents. Let's say it is 1 mm. It means that this is 0.1 mm. So the least count of our vernier is 0.1 mm. The smallest measurement, which we also call it as least count, and we also call it as the vernier constant for that vernier scale. Okay. So least count, as we discussed, 1 MSD minus 1 VSD is the answer.